I'll start the basic concepts of chemistry. Scientist Hoffman told about the chemistry. What he has written, the chemistry is the science of molecules and their transformations. It is the science not so much of the 100 elements, but of the infinite variety of molecules that may be built from them. This is the statement from Roald Hoffman. So, if we check about the science, then science can be viewed as a continuing human efforts to gain systematic knowledge. We have to stress about the systematic, this term, systematic knowledge for describing and understanding nature. Science is subdivided into various disciplines: chemistry, physics, biology, geology, etc. What is chemistry? A branch of science which studied the preparation, properties, structure, and reactions of material substances is called the chemistry. So this is the very short introduction of the chemistry. The NCERT book will get in details. So first we will see the background of development of the chemistry. Chemistry was a result of search for two interesting things. Number one, philosopher's stone. It means porosh, what is called the porosh pathar, which would convert all baser metals, it means iron and copper, into the gold. Number two, elixir of life, that means which would grant the immortality. So based on these two concepts, chemistry was developed. Chemistry was developed mainly in the form of alchemy and petrochemistry. Petrochemistry means the study of medicine and physiology. And during the 1300 to 1600 CE century. Modern chemistry took shape in the 18th century in Europe after a few centuries of alchemical traditions which was introduced in Europe by the Arabs. So what was the condition of the time in India for the developing the science, especially chemistry? Nagarjuna, one Buddhist monk, was a great Indian scientist. He was a reputed chemist and alchemist and metallurgist. His work is dealt with the formulation of the mercury compounds. He has also discussed methods for the extraction of metals like gold, silver, tin, and copper. A book appeared around the 800th century. It explains the use of various furnaces, ovens, and crucibles for different purposes. It discussed methods by which metals could be identified by flame color. Another great personality is a Chakropani, discovered the mercury sulfide, and the credit for the inventing soap also with him. He used the mustard oil and some alkali for the preparation of the soap. Indian began making soap in the 18th century. Oil of Iranda and seeds of mohua plants and calcium carbonate are used for making the soap. Even long back, during the Ajanta and Ellora times, whatever painting they used. You can see that till now what is the bright color of it, and this is the achievement, high level achievement of science in our ancient India. Now we'll discuss about the importance of chemistry. Chemistry plays a central role in science and is often interconnected with other branches of science. Principles of chemistry are applicable in diverse areas, as for example, weather patterns, functioning of brains, operation of a computer, production in chemical industries, manufacturing of fertilizer, alkali, acid, salts, dyes, polymers, drugs, soaps, detergents, metals, alloy, etc. Almost in every field for the manufacturers, including the new materials. Now we'll start the nature of the matter. Anything which has mass and occupying space is called matter. The first thing we have to remember this. Anything which has the mass and space is called the matter. That means everything around us. For example, the NCERT books. Then whatever you are using, pencil and water, what we are drinking, and air also. Nowadays, you know that during the COVID scenario, is the painful things that there is the short of oxygen supply. So this is also the matter. And all living beings, etc., are composed of matter. Because they have mass and they occupy space. Now, state of matter. Matter can exist in three physical states: solids, liquids, and gas. The constituent particles of matter in these three states can be represented as solid, liquid, and gas. You can see solids, every particles, how much orderly arranged and closely packed, and liquid comparatively less packed than the solid, and gas, each particle is moving around the flux. So the particles held very close to each other in solids in an orderly fashion, and there is not much freedom of movement. You can see with this figure. But if you consider the liquid, in liquids the particles are close to each other, but they can move around. But for gas, what happens? This gas, in gases, the particles are far apart as compared to those present in solids or liquid states, and their movement is easy and fast. That means if you open this flux, then whatever gas is inside, it will come to outside. So different states of matter exhibits the following characteristics. Number one, solids have definite volume and definite shape. Liquids have definite volume but do not have definite shape. They take the shapes of the container in which they are placed. But gas does not have any definite volume and definite shape. They completely occupy the space in the container in which they are placed. These three states of the matter, whatever we discussed now, are interconvertible. How? These three states of matter are interconvertible by changing the conditions of temperatures and pressures. Now you understood that two different things has come now, temperature and pressure. So in solids, if you put the heat, then it will convert to liquid, and again if you put the heat, it will convert to the gas. And again from the gas, if you cool, then it will convert to the liquid, and again the liquid, if you cool, then it will convert to the solid form. On heating, solid usually changes to a liquid, and the liquid on further heating changes to the gas or vapor, and in the reverse process it will again come to through liquid to in the solid form.